So, Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Aizat by Aiman Aizat. So, this is my project. I'm from DME 43 Rabu. My ID is alam018921. So, what I did for my project is a 4-stroke engine with 2 cylinders. As you can see here, there are 2 pistons and here are the motions. So this is the motion of the engine. So as you can see, there are many components of the engine, and first of all I'm going to explain how I did this screen part here, the engine block. Okay, for the engine block, okay, first I'm going to off the camera. So this is the engine block. How I did is, first step I created lines here, lines and a circle with radius approximately here, and I extrude those actually to 25 millimeters. Next, after I extrude both, I extrude cut it from the top here. I did 2 circles and extrude cut it through 20 millimeters. Next, the edges. Okay, after I extrude cut here, as you can see, at the bottom of the engine block is solid, so on the side I make a circle and extrude cut it through all. After that, I created a plane by selecting here the reference geometry plane. Okay, and I choose this top surface here and 1.5 millimeter field offset. Okay, 1.5 millimeters and I field offset. Okay. Okay, for cut extrude 6 edit features. So after that I draw from the plane I selected, I choose normal 2 and I draw circles here, lines, and I extrude cut it through 9 millimeters. Okay. Next, I did the fins here. How I did is okay. How I did is I draw lines here and lines here and circles, and I created a center line and I choose revolve somewhere revolve. Okay, I just revolve space here, edit choose, and I revolve it to 156 degrees. Okay. Next, I choose linear pattern. Here, linear patterns to create fins here, because there's no only fins is this side but not on this side. So I choose linear pattern, and the distance between the patterns are 12 millimeters and 2 patterns I choose. So the direction I choose is this line, H, the H of the engine. Okay. Okay. Next I draw a circle to cut this fins, this extrude fins. So we don't want it. So I draw a circle from the top of surface here and I extrude cut it. Okay. Next step is okay. So I did make here. I draw a circle from this surface and I almost extrude it to two ways. As you can see here, one going this direction 0.5 millimeters and the other direction is 1 millimeters. And I did linear pattern to create three of this crankshaft section here. Linear pattern 2. Okay. And I choose this edge here for the direction with 12 millimeter spacing and 3 patterns. So this is how it will produce. Okay. Next, next I created a circle here to extrude it a little bit more, and 0.2 millimeters only, because if linear patterns they are the same size, but I want here to be thicker, so I increase it to 0.2 millimeters. Next, I extrude again. I draw circles here. Draw circles at the middle of the crankshaft base. And I did it to the same way, two ways, one 0.5 millimeters and the other is 1.6 millimeters. This is for the bearing actually. Then of course I did linear pattern to make 3 patterns here. Linear pattern, cross extrude. Okay. Next, cross extrude. Okay, from the top of the plane, I select this flat surface here and I draw circles with lines and I extrude it to 2 millimeters. Okay, so it will make this part here. Okay, next step, I choose the surface and I draw lines, this center line, and I extrude it to 2 millimeters. And then to make this part here, I choose linear pattern, so from the part here I select it, let those extrude 7 part, and I create the spaces between them is 22.8 millimeters with 2 patterns, and the direction I choose H1 here. Okay. 124. Next is boss extrude 8. On boss extrude 8, I draw circles. These two directions, one is 0.3 millimeters, the other is 2.3 millimeters. Okay, and the same thing I made linear pattern again. From I select this cross extrude 8 and I did linear pattern with distance 22.8 millimeters with 2 patterns, and the direction I chose H1. Okay. cut extrude it. For cut extrude it is to make patterns right here. So here, cut extrude it. Okay, as you can see, I did some lines and circles here and here. What I did is I draw a center line and I just mirror this line to this one. Okay. Next, revolve tree. What I did here is I did a line here, a line that is from here to here with a center line with a distance 8.5 millimeters, and I make a circle, a semicircle with 10 millimeters. Then I offset entities of the line to 0.12 millimeters, and then I revolve it around here for 150 degrees. Okay. Next, because just now we did this part only, I did linear pattern to create another part here. Okay, this distance between them is 7 millimeters and 2 patterns, and the direction I choose is this line. Okay. Okay, for cut extrude now is I draw 2 circles from top of the surface here and extrude cut it. I choose this surface, I draw circles and I extrude cut from the post of the cylinder switch. Okay, next is those extrude line. Okay, what I did is I draw some semicircles here and here, and this will make a pattern that will extrude through the cylinder here. But I did only this thing is 0.8 millimeters, but I offset it to 3.25 millimeters, so it will start the extrude from here only. Okay. Then I created plane 2. For the plane 2, I selected this surface and I created a plane. I created a plane with this surface with 340 degrees of angle. Okay. So what's the plane for is to make a hole here. A hole here. How I did is I extrude cut it. Extrude cut it from the plane just now. Sorry. Okay. So from the plane just now I draw a circle and extrude cut it through the cylinders. I did 1 and 2 of the cylinders here. So let's extrude 10. Okay, for those extrude 10, I select the surface here and I draw some lines and circles to extrude it through here, so we can make like a handle for the engine cylinders for the mounting to the For example, motorcycle frame. Okay, next. Yeah. Okay, next. Okay, also extrusion. Okay, there's no already some extrusion here. So because it's only here, I did some mini patterns to make it three. Mini pattern 10. This is of 12 millimeters. 3 patterns and I choose the direction here. So what part is I choose the both extrusion just now. Okay. Okay. Next to make it much more pleasing to I did some fillet on the inner side of the engine. So I chose 4 edges is 0.5 millimeters. Okay. Next step is I did some. I choose this surface here and I draw lines and circles and I offset it to 5.5 millimeters so the extrusion will start far from here and the thickness of this part is 2 millimeters. So in pattern 11 is I make adjust this boss actor 11 part here and I make 2 patterns with 12 millimeter distance and the direction I choose this line. Okay, cut extrude. Cut extrude is very simple. I just make just this surface. I draw circles and extrude it through all of the part here. So I make fillet. I just choose 4 of the corners before that, and I make fillet with 0.5 millimeters. So cut extrude shelf. Okay, for cut extrude shelf, I did some breakwork because I don't want this part, so I just draw a rectangle here. So I select this first, and I extrude cut through all. Okay. So what I did is I make a new pattern, a new sketch. So just now as we cut rectangle here, I did a new sketch and I draw this shape and I extrude it for 1.0 millimeters. Okay. And I did linear pattern here to make it 3 of the patterns. With 12 millimeters of spacing with 3 patterns, 3 instances. In direction, I choose this line. Okay. And lastly, what I did is from the plane to just now, I draw some circles and extrude it through the hole here to make the hole valves for the spring valves. Okay, I offset it to 1.9 millimeters from plane 2. The direction is 0.5 millimeters. The thickness of this part here is 0.5 millimeters. And I select thin picture to make it this pattern 0.1 mm. Okay, so that's for the engine cylinder. Now I'm going to explain about the piston. Okay, for the piston here, how I did is I mix very a lot of lines here. I make this pattern. Okay, and I make a center line here, and I revolve it. I revolve to 360 degrees to make the shape of a piston. Okay, then after it is revolved, I cross extrude to make the patterns here. Okay, I select the surface, I draw lines here and here, so I extrude it to make this the part under the piston. Okay, what I did is I select up to next, up to the surface here. Okay, for the third step, I make cut extrude to make okay, I make cut extrude to from this origin here. I draw circles and I extrude cut it through all in both directions, so I can make the place for the piston pin. Okay. Okay, sorry, I'm going to explain about how I did the piston pin. For the piston pin, okay, how I did is very simple. I just draw a circle. I make a simple circle and I extrude it forward to 9.5 millimeters, and I fillet it on both sides of the pin. Okay, you see I select I select those parts here, and this fillet of 0.1 millimeters. So that's all for the piston pin. And now I'm going to explain how I did the camshaft. Okay, as you can see here, I made the camshaft with the sprocket here. So the first step, how I did is make a simple circle, two circles, and I extrude it for 1.8 millimeters. Next, I made the shaft here at the middle of the circle, and I extrude it to 5.92 millimeters. Next, I make circles here, and I extrude it to 0.5 millimeters. Now, to cut it to make the pattern of the gear teeth, so I first cut it how I cut it is I make some patterns, some shape here. I select the surface and I make a shape like this, so it will cut through the part here. I select through all to cut through the part. Next, I chose circular pattern. So what I did is I chose 360 degrees all around this part, and I chose 58. So there will be 58 teeth for to create a D. And I choose the direction one that I have made just now. Okay. Now, as you can see, the gears, the tooth part of the gears are actually slanted a bit and not straight. So how I did is I did flex. That is, I choose insert. Okay, insert, and I choose features, and I choose flex here. So, and I click flex. And there will be two surfaces from the origin. So let me try it here. Straight. Now x-axis I keep it 0 degrees, y-axis 0 degrees, and the z I choose 270 degrees. So the trim plane 1, I make the distance 4.35 millimeters, and the trim plane 2 I keep it 0 millimeters. But after how I did the slanting part here is here. I chose twisting, and I twist it about 338 degrees. That means this plane and this plane are rotated 38 degrees to each other. So that's how I make the gear teeth. Next, I make cut extrude. For cut extrude, I just draw one circle here. So okay, for cut extrude, okay, for cut extrude, I draw. So I make construction line of circles. I draw one circle and I make linear pattern. Sorry. I chose circular pattern, so it will make 7 holes here, and I extrude cut it until the back of the gear. So for extrude cut 7, both extrude 7, I extend the shaft here to make it longer for 29.8 millimeters. How I did is I draw a circle from the surface and I cross extrude it until here. Okay, before that, cross extrude 6. Okay, for both extrude 6, what I did is I just draw circle around the gears, and I made it a little bit uh, thicker for this part with 0.1 mm. Okay, so when I have already explained this now, then to create the cam loop here, the cam loop. Okay, how I did is I make a plane. As usual, I click reference geometry, I click plane. So, okay, from the origin, I click from phase 1, sorry, from phase 1, okay, I make some offset about 21 millimeters from the first phase here, 21 millimeters, so to create a plane here. So for both extrude it, so here how I draw the cam loop from the plane just now. I just make a camshaft pattern and I extrude it 0.8 millimeters, but I choose mid-plane, so it will be centered from the plane I make just now. Mid-plane 0.8 millimeters. Next, I make plane 2 to make the second plane from the first cam loop, so I can make the second cam loop. Okay, the same thing, I make it offset from pin 1 to pin 2 is 12 millimeters. The same thing, I just draw simple camshaft shape with, I think I use arc, 3-point arc to make the patterns here. And I choose mid-plane from the middle of plane and thickness 0.8 millimeters from the midpoint. So that's how I make the camshaft piece, the sprocket. And now I am going to explain how I did the push rod. Okay, for the push rod, or the other name is connecting rod. How I did is, okay, open the file. So this is the connecting rod. It's very simple. How I did is, first I choose something and I choose sketch and I draw some pattern. Okay, so what I did is I draw circles here, a circle, the outer circle, the inner circle. Then I draw a center line with a distance 13.69, and I draw another circle here. And I just make one line from here to here and here to here. So I distance between the endpoint is 3.3 here and 1.5 for this part. Then at the middle here I make like a small hole, but not actually a hole. There's a pattern. There's a straight line and half circle at both of the side. Okay, then I extrude it for 1 millimeter thickness from midpoint, so it will be 2 millimeters. But the extrude actually is for the circle part here, not this center part here. Okay, for post extrusion, then only I extrude this part here with 0.8 millimeters thickness. This now is 1 millimeters from it, but this one is 0.8 millimeters. Okay. What's extrude for? So just now is this part here, not the center of the connecting rod. The center here, I select this one, and I extrude it to 0.6 millimeters from mid plane. Okay, step was extrude 5 is I select the surface, okay, and I extrude it to both. I select this plane here, and I draw a simple circle, and I extrude it to both directions. One is 1.5 and second is 2.5 millimeters. Okay, I cut extrude. Okay, what I did here is I choose this surface and I draw this pattern here, so I can cut through this connecting rod. Is 11.5. This is a random number, but from the mid plane I just drawn here. Okay, for cut extrude 2. Okay, for cut extrude 2 is I just cut in middle here, because it allows us to make two separate parts. So when we assemble into the piston pin, into the crankshaft, it will be able to be assembled easily. If not, we are unable to put into the crankshaft part. Okay, so that's all for connecting rod. Now I'm going to explain how I did the crankshaft base sprocket. Next, I'm going to explain about the crankshaft. For the crankshaft, actually, it is separated with the sprocket. Okay, so this is the crankshaft. And what I did is first I make a simple sketch of this shape. I just draw this line, and I draw a center line. So I just mirror it, so it will be the same on both sides. So for both extrude, the next step I extrude here. After I did this part, I extrude this, make a simple circle, and the distance from the center here I make 5.6 millimeters, and the thickness of the extrude is 2 millimeters. And I make the middle part of the crankshaft. I extrude it to 3.26 millimeters. So what I did next step is I choose mirror. I choose all of the parts here, also extrude, and I mirrored it from this one here as the center. Okay. Then it will be like two parts here, but I want this part to be longer, so I just make a simple circle and I extrude it to 3.34 millimeters. And for the last thing I did is I make some extrude cut here. For the crankshaft pins, I select the surface, I draw some rectangle, a rectangle, and I just extrude cut it, not through all, but for 0.1 meters only. Okay. So that's for the crankshaft. Now I'm going to explain about the crankshaft sprocket. Okay, for the crankshaft sprocket, first I make the shaft. This is simple circle. So this 5mm extrude. Then I make this part to extrude to the opposite side with 4mm. For part 3, after that, from the surface here, I make a circle and I offset it for 1mm. So and the thickness of extrusion is 2.8mm. So cut extrude 1. To make the teeth of the view, I draw this shape here from this surface that I selected. I draw this shape and I cut extrude through all, so it will be able to make the teeth over here. Okay, but I make a place for the pin first, for the crankshaft pin. So I just make a simple rectangle from this surface and I extrude boss it to 2.6mm. Okay, now I will explain how I did the teeth of the crankshaft. First, I select circular pattern from here, circular pattern. So I chose 360 degrees from this center point from phase 1, and so I will make this around this part here with 90 teeth. Okay, so it will make the pattern around this shape. Okay, now as you can see it's a bit slanted. What I did is flex 1, the same as the crankshaft I did before. Is I choose insert and features, and I choose flex here. Okay, after I choose flex, okay, I choose the circular pattern that we have made just now, and I choose twisting. Then for the triad is here, from 0 I change to 180 degrees. For x-axis, for axis is 0 degrees. Z I choose 180 degrees. So the plane will be like this. The trim plane, for trim plane 1, the distance between the center is 5.3mm and the trim plane 2 is 0.74mm. For the rotation between the plane 1 and plane 2 is negative 19 degrees. Okay. For cut extrude, it's a simple circle. I choose this plane, make a circle, and I make a circular pattern with 5 holes here, and I boss extrude this part. This I select this surface and make a circle, and this I extrude it a little bit, cut the ball, Okay, how I did is I make a pattern here from the center line. I make a rectangle pattern, so it will be able to cut revolve through the gears 360 degrees. Okay, so it will be like this. Chamfer. So I select the surface to make a chamfer from here, chamfer, and it's just so I like this edge here is 45 degrees, 0.3 millimeters of chamfer. So that is for the crankshaft sprocket. Now I'm going to explain about push rod. So push out, okay, the push rod. Okay, push rod. Now for push rod, first step is a simple circle with extrusion at mid part here at A of the inner circle here, 15.5 millimeters. Was extrude for the outer circle, I extrude it to the opposite direction of 4.75 millimeters. I just fill it to make this part a little bit circular with radius 0.2 millimeters. Was extrude, I select the surface here and extrude it for 0.3 millimeters. So the radius of the circle is 1.7. Sorry, the diameter of the circle here is 1.7 millimeters. Next is the bow. Okay, for this bow, see, for this bow, I just choose the center of the circle here and I make this pattern, so I can make a place for the rocker arm. Okay, this part here, and I just choose revolve and revolve it for 360 degrees. Okay, so just now the part here is hollow, but I want it to make it solid here. So what I did is from the center line, I draw a rectangle pattern and I just revolve and just revolve it to 360 degrees. Then I cut revolve from the center line. From the center line here, I just make a rectangle and I cut revolve through the part here for 360 degrees. Okay, so this is what I did. Okay, so this is for the push rod. Now I'm going to explain to you about the rocker arm. For the rocker arm, so first step is This is a simple circle. I make this pattern, this circle here and here, and a 3-point arc. So I extrude this circle only for 2 millimeters with mid plane, and I extrude this part for 1.4 millimeters mid plane. And for this part between the two circles, 1.2 millimeters, and this part is 1.2 millimeters mid plane. Then what I do is from this part here, from the side part, I draw this shape with some semicircles with straight lines, and I just revolve it through 360 degrees to make the part just now. Okay. Next, I draw some midline. I just make a rectangle line and I revolve it 360 degrees to make this the middle part here. And for the top part here, I draw 1, 2, 3, 4, 5, 6 hexagon with very simple little angle. I've calculated the distance between here and here is 1.3 millimeters, and this part I extrude it. This is a simple circle and extrude it 0.4 millimeters. So that's all for rocker arm. Next, I'm going to explain about the valve. Okay, first how I did is I draw a shape. As you can see here, I draw shapes and I revolve it, revolve both ways to make the valve, and that is for the valve stem and all the parts here except the spring. And for the spring, how I did is first I make a circle on top here. I sketch a circle, then I choose curves, then I choose helix and spiral. So from the helix and spiral, I choose pitch 0.2, 5.5 revolutions, and the start angle is 270 degrees clockwise. So that's how I make the spiral. Next, how I make the spring thickness with the spiral thickness. First, I draw a circle, a small circle here. This is a simple circle, and I make the diameter same as the diameter of the circle. Sorry. And I choose swap both space. Okay, just now I make a circle of diameter 0.06 millimeters. Then only I sweep both base. I choose the circle, sketch 3, and for the plane, I choose the helix or the spiral just now. Then I choose here bi-directional. This one is direction 1 is the left, bi-directional on both sides, and this one is direction 2 for right side only, but I choose bi-directional. So that's how I make the valve piece string. Now I'm going to explain how I make the arbor. Okay, arbor. So the arbor is very easy. I draw a very long shaft with 0.6 diameter, and I expose it to 26 millimeters. Next, from the center line of the shaft, I draw 4 rectangles with some distance from the end. I just make a simple rectangle, 4 rectangles, and I revolve it. I revolve 360 degrees around the shaft. So that's how I make the arbor. Okay, so that's all how I make the components. Now I'm going to explain how I did the assembly. For the assembly, we will open back the assembly. So this is the assembly. First, how I did the assembly is I make the engine block as the fixed part, and then I insert component. There is crankshaft, the crankshaft one here. Okay, the blue crankshaft. So what I did at crankshaft 1 is, first I concentric engine block 1 and the crankshaft 1 is the surface here, and the inner surface of the engine block. I concentric it, I made it. Then the distance, I make some distance between the surface of the crankshaft and the surface of inner engine block. Second, parallel, I make I make the crankshaft 1 and the crankshaft 2 parallel together. So as you can see here, this part and this part I make it parallel. Then for this first and second crankshaft, I make it meet together, coincident together, so it will attach together. Then crankshaft 1 here, I make it meet this, concentric is the center part of the connecting rod and the center part of the crankshaft part here. Then I made it with the surface of the crankshaft and the outer circular surface of the push rod. So that's how I do for most of the crankshaft. For the camshaft sprocket, okay, first I made it with the crankshaft, and then I parallel the pin with this pin here, so it makes easier for assembly. Okay, and then I did some advanced mechanical mate. I choose gears and there is a ratio. I just set it as default, and they are made. Okay. So for the camshaft, this is the camshaft. So this is the camshaft. What I did is first I made it. Okay, I made it this surface here, this surface of the camshaft, and the inner surface inside here of the block. Then I set the distance between this surface, this surface and this surface for a certain distance, and I chose made of mechanical parts for camshaft, and I made these two parts, these two surfaces together, one for this part and another is for this part here, camshaft and the push rods. So for gears, I choose made, and there is advanced mechanical, and I choose gears, and the ratios I just keep it default, and that's how I made the camshafts. Okay, next for push rods. For push rods, first I select the surface of the push rods and the surface of this inner part here. I made it together, and then for camshaft made, there is a camshaft option at the mechanical settings here, option here. As you can see, first I select mechanical, and I choose cam path. Phase 1 is the phase of the cam rope, and the cam follower is the inner part of at the bottom part of the push rod. Mid type I choose cam. Okay. Next, tangent. So I select the rocker arm surface here, and also the surface of the top part of the push rod. As you can see, just a standard mid. I choose no surface, and I choose tangent. Okay, that's the how I made push rod 1 and also push rod 2, the same thing. Next, the arbor. Okay, for the arbor, so this is the arbor, the brown part here, arbor. What I did is first I made this orange part, okay, this surface of the arbor shaft and the inner part of the engine block right here. Second is the distance between the leftmost surface of the arbor and the surface of the engine block here, and I set it to a distance of an offset of distance of 0.15 millimeters. Okay, so I show you again, 0.15 millimeters. Okay, next I concentrate between the arbor and the rocker arm, means I made them means the center of the arbor and the center of the rocker arm is concentric to each other. Next, the arbor and rocker arm. This surface of the rocker arm and the purple surface of the arbor are made together. Next is concentric. The middle part of the arbor are concentric together to the middle part of the rocker arm in the orange color. And then the same thing, I made two surfaces together. The orange surface, that is the surface of the rocker arm, and the purple part, that is the surface of the arbor. Okay, so that's all for the arbor. Okay, next rocker arm. For both rocker arms 1 and 2. Okay, this is the rocker arm. What I did is, first, as usual, I concentrate just now. As I explained, I already concentrate the shaft of the arbor and the center part of the rocker arm. Next, the coincident, as I explained just now. Tangent 2, as I explained during the push rods, and also the ball of the push rods. I make it parallel, I make it tangent, and also for the tangent 4. Okay, tangent 4 here is I choose this surface and this surface of the valve, the top of the valve, to be made together. Okay. Yes, so these two surfaces I choose tangent because they are 90 degrees together. They are tangent together. Okay. Next. For the connecting rod. So connecting rod 1 and 2. So this is connecting rod 1, this is connecting rod 2. What I did is, okay, first I already explained during the mid of crankshaft, I concentrate between the center of the bottom push rod here and the center of and the center of the circle. And the center of the mid part of the crankshaft. Then the outer side is made together with the inner side of the crankshaft, and here is I make the center of the push rod circle here as concentric to the piston pin. Okay. Let's go to the piston pin. Okay. Piston pin. Okay, piston. Sorry. Connecting piston. Next, for the piston. Okay, for the piston, first I make it concentric with the center of the engine cylinder and also the piston. The center of the piston and the center of cylinder wall are concentric together. And yes, the center of the piston hole here are concentric together with the center of piston pin. They are made, means the piston pin are made to the inside of the piston, and the piston rings here are made to the engine, to the surface of the engine cylinder, to the cylinder wall. Okay, piston 1 and 2. Next, for the width, okay, for width, actually is the center of the of this both part and the face of these two surface here are centered together, so they are both in line, and the piston placed at the position and doesn't run to the left and right. So there is a function of the width here I choose at the advanced setting, mid advanced setting. The V section is the blue part and the tab selection are the purple part. So that's for the connecting, for the piston pin. Same as piston 2, the same method, that I have made with piston 1 and also to the piston 2. So here is the valve. Okay, next for the valve. Here's the valve. Okay, what I did is I made the center of the, sorry, not center, the surface of the valve to the inner side of this hole here of the cylinder, engine cylinder block on the top part of the engine cylinder block. So I made it the two surface together, and here is the tangent as I explained before this. They are 90 degrees together. Okay, so that's how I made both, that's how I assemble this 4-stroke engine with 2 cylinders. So as you can see here, it is able to be rotated. Okay, you can see the camshafts are following the profile, the push rod are following the profile of the camshafts. Here it is pushing the rocker arm and causes the valve to be open and closed. Here is valve, the valve is open, and here is valve is closed. Sorry. Okay, here is valve open. Sorry, this is the valve closed, and when the push rod pushes down the valves, then the valve is open. Okay, you can see here is the valve is open, and here the valve is closed. Okay. So this is valve open, valve closed, and this is valve open. Okay, so that's how I assemble the engine. For the exploded view, I just chose the exploded view, and I chose part by part on which direction. For example, I chose this part and I just drag it to where I want. So I will show and what it will, and the result of the exploded view is this. Sorry, I will start again. is the result. Okay, so that is for the exploded view. So that is all from me. Thank you and have a good day.